Hi, I'm Danny Thomas from Netflix. I'm not John Schneider. John, his wife is about to give birth to their second child. He actually did make it today, but there's every chance he'll have to rush out of here. So I scrambled to prepare for this last night. So apologies if I'm head down a little. I'll be relying pretty heavily on my notes, but I'll muddle through. So I'm here to talk about dependency management at Netflix. I'm with the Build Tools team. We're part of engineering tools at Netflix. We're responsible for all of the common build and deployment pipeline. So you might be familiar with ASTRID or our Project Spinnaker for our delivery engineering folks, and some of those folks are here. And we're responsible for Nebula and our build infrastructure, all based on Gradle, obviously. I started with the company in February. I came from London in the UK via London. I'm Australian, I should say. So if you're unfamiliar with the Netflix culture, it might take you by surprise just how much it informs what we do and don't do. Teams are highly coupled, but rather loosely coupled, but highly aligned. And we encourage responsible behavior through providing context. You know, as a team, we can't tell you how to build your software. We can't dictate what tools you use. We can't tell you, which practices to follow. But it's our job to inform you and provide you with a path that works. And it makes for interesting challenges. And because we can't just top-down control what's going on at Netflix in development, in product development, we have some interesting challenges, and they're really reflected in our dependency landscape and the issues we have with dependency management. So we're unequivocally a binary integration organization. There's a lot of talk recently about build from head, about Blaze and mono repositories, and we feel that doesn't really align with our culture. Again, it's very much about top-down control, and while we do see the benefits of both, while it would definitely make our lives far easier if we could adopt some of those things, we feel that it imposes too much control and too many opinions. And we tie ourselves in knots a lot on the team, talking about, well, we would love to do this, but we can't. It doesn't fit within the culture we have. It would impose too many opinions on our teams. Now, we also like that not imposing too many opinions means that we're solving problems in a way that scales up and scales down. We don't do a lot of things like, we don't try to solve problems in a way that's unique to Netflix. We try to solve the general purpose problem, which means that our solutions scale up with us or scale down to the average Gradle or build system user. This will focus heavily on our JVM ecosystem. However, the ideology informs our polyglot efforts, particularly JavaScript is something we're working a lot, just like LinkedIn. We're taking a very similar approach. But we're very much about, if we can wait and see how the landscape unfolds, we will wait rather than leapfrog teams. So dependency management occurs in a vast microservice landscape at Netflix. However, thin services don't mean thin dependencies, nor thin clients. So on the server side, we carry a pretty significant legacy of Netflix streaming formerly being a monolithic service, a single container. And so much of the platform and the common services such as discovery and some of the service reliability infrastructure is a common set of libraries that everyone carries with them. So when we're managing dependencies, you get unexpected side effects, and the further you are down the tree, the more likely you are to be affected by your upstreams. The fat clients are necessitated by fallback and reliability strategies. Our clients are not thin. All of the logic that keeps Netflix running, the reason we can survive chaos is because our clients are responsible for fallback, for retries, for recovery strategies. If one request fails, we might return a canned response or a fallback response or a cheaper response. We may the client knows how long that its entire microservice chain will take. So if it knows the next 3 service calls are going to take longer than the timeout, it won't make them at all and short circuit at that point. So all of that is happening in the services, so that means the clients carried that burden. And also it's very common for the service and the client to share some responsibility. So often common service dependencies leak into the client and their dependencies come with. So often clients are fat because they bring a whole bunch of dependencies with them. Because we can't tell you as a team which dependencies you can and can't use, you may have different versions of JSON libraries, date libraries, whatever it might be. And that, if you're at a service level, that's fine because you deploy in a single container and you don't affect anyone downstream. But when your clients leak and are pushed down right to the edge, that causes a lot of side effects. So another cultural tenet is context, not control. And I sort of mentioned a little bit about this already, is that we don't own builds at Netflix. Our role is not to own your build, to tell you how you build. Our role is a productivity multiplier. We're there because we're experts in builds and in dependencies, and we try to smooth the path in front of you as much as possible. But we don't have the ability to tell you what to do. And importantly, ideas, tools, approaches live and die on their merits. If we're not meeting your needs with our build infrastructure, chances are you're going to go and build something else. Our engineers are amazing. And very often teams will leapfrog us and we'll play catch up as we go, wow, that's a great idea. We really should bring that into our stable and make it available for everyone rather than it being just for that team. And responsible behavior is encouraged, not forced. We make the actions of the consequences of your action clear. If you're being a bad dependency citizen, we try and inform you what the right thing will be doing. But if you choose to do what we might say is an irresponsible thing, you're completely free to do so. And the consequences are what they are. But sometimes opinions are useful. So Nebula is the umbrella that it's sort of a dual umbrella. So first, it's our open source Gradle plugin effort, but it's also the umbrella on which our internal opinions live under. So things like repositories, what manifest metadata dependencies carry. There are a lot of things that we do have to control simply because, one, you don't want to push it all the way down to the team, every team, and two, because we want these things to be consistent because it allows us to understand, particularly dependencies at Netflix. Those opinions are what we call our paved road. So if you stay on our road which is quite heavily traveled at Netflix, you cede some control to us, but we solve a lot of problems for you. And we try to make the plugins we create as general purpose as possible, because it benefits the community at large. So when we open source these things, they're applicable to everyone. It means that we don't couple those plugins to our internal requirements, and it means that we're likely to get the longest life out of those things. Generally speaking, if we write a plugin that's a one-off thing, it's going to be instant technical debt, and we're going to be just paying it down later. Again, teams are free to select a build tool that works for them. If they want to diverge from the Gradle Nebula road, they're free to do so. We'll help with, make sure you add this manifest file, or this is how you publish to Artifactory. But we make it pretty clear that if you're going to forge off on your own, support is going to only come if we see some serious adoption, and it makes sense for us to support it at an engineering tools team level. With those opinions, it's really important to avoid magic. You diverge from default behavior at your peril, which is a lesson we've learned quite painfully. In some cases, and rightfully so, we've eased legacy migration by accommodating for legacy properties or external, certain dependency publishing practices. Like we have a custom Artifactory Ivy layout, and that just those things come back to bite us. Because we haven't paid down that debt early. When somebody wants to use SBT, or when somebody wants to use another tool to talk to Artifactory, they all have to declare our custom layout, or they all have to declare our custom metadata strategy. So we feel like at this point, diverging from that is a bad idea, and we want to keep problems and documentation Googleable. If it's something Gradle related, and we've changed the behavior and it's not obvious, that's really uncool. And we've done that quite a bit. So one of our big efforts this year is to sort of, now we've migrated from our legacy Ant infrastructure and all of the legacy stuff that required that. Now we'll take the opportunity to consolidate and pay down that debt and bring everyone really well up to date, so we can keep moving forward with new releases of Gradle. I should say we avoid leaning too heavily on Gradle's resolution mediation tools. So that is, we love resolution strategies and component selection and all of those things, and we use them quite heavily in our plugins, but we try to do so in a way that is somewhat build system agnostic, in that if you did the same thing with another tool, it would work against our repository, for instance. Like dependency locking, I'll talk about in a second, is a good example of that. Now, that may not be right for you, but given our culture and the fact that we want to make sure that even if we're not supporting you directly, we're supporting you implicitly, we try not to be too opinionated about that stuff and build too much magic into the dependency resolution process. Now, teams at Netflix are focused on shipping features, and rightfully so. I mean, this is why we're there. But they don't always realize their impact on downstream consumers in doing so. And in effect, they end up slowing everyone else down, particularly if you're high in the dependency graph and you have a lot of downstream consumers, or you can cause side effects to everyone because of the way conflict resolution works. The right way isn't always obvious. Transitive dependency management is complex. Mediating the process requires a deep understanding of the libraries in a project. Often people have inherited projects. They have no idea why they have a dependency on something. They don't know if it's safe to remove. Their test coverage might not be adequate to give them the confidence to either upgrade or to remove a dependency. And we on the Build Tools team, we live and breathe dependencies every day. So it's really hard for the average, well, we find it's really hard for the average engineer at Netflix to really keep on top of these things. And we also need to cater to different audience. Not all people who build software at Netflix, I would say in any organization, are in it for the craft. I find like our team, certainly, we're engineers for the sake of engineering. We love the craft of software. But for other people, it's a means to an end. We have data scientists, we have protocol experts, we have encoding experts, where software is a means to an end. Like they're not there, they're not focused on dependencies and unit tests and those things because that's not their expertise. And so it's our job to cater for both of those audiences. So a little on our strategies, in which I get to the point. First is to inform. So let people know when they're doing something harmful and when they're doing something well. In particular, you try to turn your knowledge into organizational memory. Don't underestimate your ability to infect the organization by informing like-minded people. Most developers, if you explain to them, would do the right thing if they knew what the right thing was. In a large, complex dependency graph, you have no idea who you're affecting downstream, or because the graph is both deep and it's wide, and it could be hundreds of dependencies involved in conflict resolution, and you have no idea what's going on. So if you can inform people about the wrong thing or the right thing to do, chances are they'll do or don't do that. And make every interaction with your customers, and we do call the teams at Netflix are our customers. Really, we're a customer service organization. We make every interaction with them an opportunity to push and pull them in the right direction. If we see something in their build that we don't like, we explain why. If we see a dependency that they can remove, we let them know. Or particularly if we see people breaking downstream a lot because of a project, we'll try to go upstream to help the people up understand what they're doing to their consumers. However, that only goes so far. we have a couple of projects internally that we're working on. I think we're still talking about whether this will be OSS, but I'd hope so. So Project ASTRID is our third generation self-service dependency insight tool. So part of the problem with, say, the dependency task or dependency insight task is it's local to you. You don't see what's going on upstream, you don't see downstream, you don't see SKEW. So ASTRID helps us answer those questions about use, age, SKEW, deployments, so we can see the artifact lifecycle end to end. It also includes change campaigns. We for instance, Guava upgrades are particularly painful if you're not shading Guava because of their very strict deprecation policy. So every even version practically, there's a big effort to find all of the unused, or all of the deprecated APIs or all of the removed APIs and inform people that they need to move. And coordinating those moves, like knowing when I'm safe to change because all of my upstreams are ready or my downstreams are ready is really tricky. So this helps us with those problems. Excuse me. The second is Project Beholder. So a major anti-pattern we've found in our builds is, and it's kind of, I guess it's kind of, it's not really the Maven way, but we find that projects that don't declare their first level dependencies are bound to encounter side effects. And it's particularly when they're depending on something coming intransitively and it's removed and their build breaks. Or they get, or worse still, they get downgraded. So declaring their actual first orders, not only just, it's sort of and it's an explicit statement of this is what I'm really using, and we find that really useful. But it also means they're protecting themselves from side effects, and it interacts well with dependency locking. And then unused dependencies. Obviously, they pollute the graph. They upgrade it, or they upgrade people needlessly. If you're using Commons Lang latest or Guava latest accidentally, and you're upgrading all of your downstreams when they resolve their dependencies, that has a lot of side effects. And when we consider active inline reporting far more valuable to something like self-service like ASTRID, that's great for people who need to explore and answer complex questions and run campaigns. But for the average build owner, we really need to get up in front and center. And it kind of fits with our our practice in infrastructure, right? We have the Simian army and chaos monkeys, etc. Failing, or perhaps at least just warning that you're doing, or the context piece, right? Saying, you run this build, and here are the things that you're doing that might be harmful, is a really effective tool to get people moving in the right direction. Okay, sorry, just catching up on my notes. Let's take a second. So the particular ring of language dependency hell you're on really depends on, we've found two things. So systems like the JVM, where you have a flat class path, where you conflict resolve either by upgrading everything to the latest version or nearest first, whatever it might be, it takes fastidious dependency hygiene. Very disciplined teams, or very few interdependencies. Just don't depend on each other, just do your own thing. And that's not the case at Netflix. Either that or an ecosystem that ensures everyone got what they asked for, like NPM and Nix. Everyone just gets what they ask for, and that's partly due to the languages these tools work with. Just by their very nature, they're able to do these things. JavaScript is not typed, so you can stuff stuff in a function and it just works, right? We don't have that that ability on the JVM, but we do have module systems or constraint-based systems that can help. But limiting the versions that contribute is a great way of improving stability. If you're not skewing over 10 different versions in your graph instead of one, chances are you're going to feel fewer side effects in your projects. So build often and release often. The problems with SKEW and the things we want to address by avoiding dependencies often come from simply not building often enough. So there may be a dependency that hasn't been built in 6 months, and it depends on 6-month-old versions. And either they haven't released or they've locked to a particular version. Some teams we find will just sit on their libraries. They never want to change them. And that means they're not testing on what they're going to be run with downstream. We also have vastly different release cadences, which quickly lead to SKEW. Teams vary from weekly builds and functional tests over the weekend to true continuous delivery. There's a bit, again, freedom. Whatever works for the team is the right thing. So the release cadences contribute heavily to SKEW. But importantly, like, it leads to runtime execution paths that were not unit integration tested. If you're not building your projects often, even if there are no changes and you're not upgrading your dependencies, chances are you're going to affect, or you're going to experience side effects downstream because you break, because somebody upgrades you to one of your dependencies. Change, like chaos, is inevitable. Take the pain of change in small doses. We believe that building and releasing often is a major contributor to runtime stability, as long as you're keeping dependencies current. So as long as those builds, there's no point building and releasing something that doesn't change its dependencies. So as long as those builds are keeping things current and you're keeping close to the head, you're going to have a much better time. Curated dependencies are not for us. So we currently have walled garden repositories, or we think they're not for us. And we have a reasonably highly controlled process for bringing in external dependencies. And that's quite problematic because of how much open source we do. A lot of our projects are open source, and then there's an internal module that adds the internal only and proprietary logic to that project. And for teams who are working sort of in mixed mode between our internal repos and our internal artifact repositories in GitHub and JCenter and Maven Central, that becomes really problematic to constantly have to do another step to bring their stuff in. And in reality, we've found that folks will bring in what they need anyway. So if the data science team needs a library to do some statistical analysis, and it was designed by data scientists, so it has 50 dependencies, they need it. Like, they need to get their jobs done. So we've found that curated dependencies are, for us, at least for us, they're harmful. They add a lot of overhead and we're not seeing the benefits of that overhead. Perhaps if we were more disciplined, or a different organization with more ability to control this, maybe it'd be a better fit. But we find that it slows us down. So next is stability. Repeatability of dependency resolution is key for repeatable builds. You can't encourage people to build and release often if they can't repeat the same build twice in a row. We don't want to make teams change until they're ready. Netflix is a fast-moving organization. There are releases happening in libraries all of the time, but we don't want to make teams change until they're ready. But we also, more importantly, want to keep development environments stable. There's nothing worse than a snapshot or dependency changing from under you within 5 minutes when you're working on a problem and it breaks your build. So keeping development environments stable is really our primary goal, but it has a nice side effect of stabilizing CI and the rest of the pipeline. So we like chaos in our infrastructure, but not our build. So at Netflix, dynamic version selection, we use Ivy repos. So candidate release promotion, changing the status on the artifacts is common. We use latest.release, we use latest.candidate, we use dynamic versions with a plus, which is good because it keeps people current. But it's essentially the Maven snapshot problem in the case of all of the changing dependencies. And on top of that, the other things that Ivy adds, makes that even more complex. So that, coupled with the complex dependency graph, makes side effects inevitable. So we find that repeatable builds, this comes up most when a team pushes a release, it's got a regression, and they're like, oh God, what do? We want to roll back. And we're like, well, we don't really like antecedents. We don't want to republish an old artifact with a new version. Can you repeat the build? And then we usually go through the dance of seeing what dependencies we're using and trying to get their build repeatable so they can fork, rebuild, and it means that next time this happens, they're ready to just roll forward and roll with a regression rather than hitting the panic button and coming to engineering tools for help. So our major strategy for this is dependency locking. So Shepherd mentioned this earlier, and while ideally I think we would like it better if the repository and the SCM system and the build tool interacted more to provide us with repeatable resolves without resorting to something like as heavy-handed as dependency locking. The reality is, in today's landscape, we just have to do this. There's no better way for us to pin builds in an SCM committed file that guarantees that at least our dependency resolve is repeatable twice in a row. So the dependency lock plugin saves your current dependencies to a file and then allows you and then forces those via resolution strategy in Gradle. So we read that file, we force everything, and then ensures you get exactly what you asked for, or exactly what you used last time. We also have a global dependency lock version, which went out in a release or two in dependency lock, which locks dependencies at a root project level for everyone, because we found that we have some side effects from some shortcomings in the tooling API. I'm not sure exactly what they are. John would know better. But we find that multi-project builds in IntelliJ in particular can be prone to side effects with dependency locking if we don't, or dependencies in general, if we don't lock at the root project. That's on GitHub at Nebula Plugins, and yeah, we use that very heavily. So modularization is the next piece, and allowing conflicting versions to coexist. So modularization is certainly underutilized at Netflix, I think, and I think it feels like it's going to be the area we're going to be doing the most work towards, and that seems to align pretty nicely with both the Java and JVM roadmap and Gradle's roadmap. So we think that taking the less opinionated approach and not trying to rip out the dependency resolution mechanism and replace it with our own, or doing something even more complex than that, has been the right decision, because even though we've experienced quite a bit of short-term pain, addressing the pain as best we can through locking and other strategies means that we're better prepared for what's coming in the JVM for modularization. As it stands, Jigsaw aside, runtime modularization is problematic for the same reasons as some of the other strategies. They're far too opinionated about the runtime. They impose a lot of requirements on teams to manage their dependencies, ensure manifests are correct, ensure they're declaring their dependencies, and it's far too opinionated in what is a polyglot JVM ecosystem anyway, and just even if we were just doing pure Java, and with a single container, we feel like it would probably still be too much overhead. Your mileage will definitely vary. OSGI could be for you. JBoss modules is really interesting. I like its approach, but the documentation is non-existent. So using it outside of the container, the JBoss container, is practically not impossible, but it's a lot of work. You're doing that yourself. We are, like I said, Jigsaw, we're watching that with a lot of interest. We think, we're unsure how it'll align with our legacy and culture. The previous modularization efforts were hamstrung by discussions about version strategies, and we depend a lot on what are effectively constraints. So we're not sure how well that will address the runtime constraints, and how well or how much overhead that will place on engineers to switch to a module system. But we would hope that between what's coming in Gradle and what's coming in Java 9 rather, we'll see enough benefit to make the switch. Like the overhead imposed on developers will make so many problems disappear that it will be a no-brainer. Next is compile time modularization. So this for us is shading. Shading, for those aren't familiar, that just relocates packages, making them globally unique. John's Shadow plugin is our favorite plugin for Gradle with this. One problem with compile time modularization or shading is that it's incumbent on every build owner to decide what they're going to do in that space if they don't want to pollute their graph with a certain dependency. It results in unnecessary duplication. If you bring Guava into your project, it's like 2 megabytes or something, so you end up with a lot of class duplication. Class loading performance will be affected, and particularly your startup times will be affected because your class part will bloat rather. And when you have hundreds, like if we had the 300 most commonly used libraries at Netflix start shading their stuff, our class path would just explode, and our startup performance would tank. It can be harmful where compatibility issues arise, and it's not possible to replace that dependency. So if you've shaded something, I can't get at that thing. I can't upgrade it via one of your transitives. It can also protect you from compatibility issues, like ASM, for instance. ASM 3 and 5 aren't API compatible, or major versions may not be API compatible. So it can be a positive and a negative, but it's an interesting balancing act, and you really. And just like making a decision to remove a dependency or not publish downstream, shading requires pretty deep knowledge about the library's transitive dependencies and how it works at runtime, because there are edge cases that the shading plugins can't allow for. Externalized properties files with class names, annotation scanning, there's all kinds of things that it just doesn't handle. So something we're working on, John and I, is Project Nemo, which is just-in-time shading on the dependency consumer side. So when we were thinking about how would we address, say, class path duplication, everybody shading to different package names, we thought, well, what if we made package names unique per, like what if we had a convention for the package name, which include the artifact ID and the group ID and the version, or something like that, a common prefix, so that way we wouldn't be duplicating libraries. And then we could share those things transitively if they had different artifact IDs. And then, but then we've got the need to address the seam, because you always, if everyone down beneath you is shaded, that's fine. You don't have to see that because that's a runtime concern. But the seam between you and your first level dependencies, you need to interact with their API. So you would also have the need for first level dependencies that have unshaded packages themselves, but relocate all of their transitives. And then you have edge cases related to, I've shaded Guava, but I have multimap or optional rather, in a public API. What do we do about that? So Nemo is our project for experimenting with those things to allow people to always refer to their first level dependencies, to have those modules participate in conflict resolution in that they're not hidden. You get the full transitive graph, but those things don't conflict resolve because they have different artifact IDs. It provides a virtual repository. The implementation provides a virtual repository. It's just a Maven/Ivy repository, and does the JIT shading on request and has a cache. At the moment, the way we've approached it is the artifact ID, we just add _module to the artifact ID, and that's what kicks off the magic. And look for a preview on Netflix Skunkworks. John was going to push some stuff there. We're not sure how this research will pan out. We have found, there's a bunch of edge cases and corner cases when you're relocating packages and messing with runtime class paths. So we're not sure exactly how this pans out, but we're hoping that this will provide us some additional relief from here to modularization, true runtime modularization. And how am I doing for time? Because I think I'm running short. So maybe we can break early for lunch. So that's me. Any questions, comments? We've got some time.
I was kind of curious about how important it is for a versioning scheme with various components, like do you follow a semantic versioning approach?
It's interesting, actually. We don't currently, but we are moving our legacy Ivy versioning. So our previous build system was called CBF, and that was Ant and Ivy. And teams had various versioning strategies. And what we do is we go out to Artifactory when your build runs, and we work out, the next version number to do that. And it's quite heavy weight. It adds a lot of time to our builds. So our release plugin, which is open source, is Git tag based, so it's much faster. Because generally speaking, we don't want the versions of a multi-project build to skew. We want them all in the same version. So for teams who also desire that, they can opt out Go Semver and the Git tag based approach, which you can see an example of that on I think we're doing that on all of our OSS projects now. So Netflix OSS should have been upgraded to that new release plugin. So if you want to see an example of how that works. Yeah, so we are, but again, we can't say Netflix is Semver. It's like, but for teams who see the value, we can say, here is a plugin that will simplify your release project. It will do the tags. It will push them to Stash or GitHub and have you release. Right. Yeah.
How many teams at LinkedIn use these dependency locking capabilities?
And Netflix, you mean? Actually, it's a good question. I'm not even sure we necessarily know. One, actually, it's interesting. The build receipt stuff, we've actually just built something that effectively does build receipts. So we're hoping that will give us the insight we need on that kind of use. I mean, it would be pretty easy for me to do a Stash search and work out who has dependency lock. But it's very heavily. Like if a team isn't using dependency locking, chances are if they come to see us with a problem, we'll get them using it, right? Because there's no downside. You add a CI job once a day, nightly, runs and updates the lock, maybe runs your unit tests, and everybody comes in the morning and pulls, and they're upgraded, and they're good to go for the day's development without any side effects. And it also allows people to lock back, right? If somebody publishes something with a regression, and they're having trouble anteceding it or rolling forward, and we don't want to delete, and deleting the artifact from Artifactory does nothing because all of the caches. It's a really useful mechanism for people just to pin back, a single dependency. Yeah. Either two. I think we've got time, so I'll probably get to both of you.
Do you participate in things that is like a mono whereby like internal libraries encourage teams to pull the latest version so that everyone is sort of like working on the same?
Yeah. So as I mentioned a little earlier, we're definitely we're a binary integration shop, right? So our approach to that is things like the latest.release, latest.candidate, because we can do candidate and other module schemes because we have Ivy, or dynamic versions, 1.plus. We definitely, like some teams we've found use latest release with third-party dependencies, and we definitely warn them off that. It's a really bad idea. At least do major .plus, right? We've had people upgrade juice accidentally and that kind of thing. So, yeah, I guess that answered your question. I think I did, yeah.